Tired of clunky machine learning models that struggle with structured data? Extreme gradient boosting is here to change the game. We will kickstart with an introduction to XGBoost, the powerhouse in machine learning for structured data. We will unravel the secrets of gradient boosting, the core principle behind XGBoost. Then we will dive deep into its inner working, exploring initialization, loss functions, and the magic of decision trees. But here's the best part. You will learn by doing. We will walk you through every step from data preparation to parameter tuning, model training, and result evaluation. Finally, you will get your hands dirty with a real data set, implementing XGBoost as you learn it. So, let's get started.
Now we're going to understand about XGBoost, that how many attributes do we have in this. We're going to understand the limitations, the benefits of XGBoost. So first you can see here that XGBoost stands for extreme gradient boosting. It is an advanced version of gradient boosting. Second is, it's a decision tree based ensemble machine learning algorithm that uses a gradient boosting framework. Here, as I discussed earlier, that we are not using only one decision tree, we are using multiple prediction based of multiple decision tree, and at last we come to the conclusion that which one, when we find the average of the prediction, then the last prediction would be the best one. So it's like trying different pair of shoes, and when you try different pair of shoes, then only you will be able to understand that which one is the best one for that. So here you can see that I have given a formula. That formula is nothing but is a mathematical notation of XGBoost. I'll explain you one by one all these variables. First you can see that here that LT is given. Before the LT, I'll explain you the meaning of this summation. Okay, so first is here you can see that summation, that what is the meaning of summation over here is that we are adding everything, several terms together. So the summation in itself explains that the sum. So the meaning of this is adding all the terms together. So we are doing that sum over here. Next is why we are adding all these terms over here, because we are doing this for each data point what we have in data set. So it starts from like first value to the nth values, means to the last, till the last value. So it sum it up all those. Next point comes over here is the meaning of LT over here. So then what is the meaning of that? It is the loss function. Now what does it mean? The L over here is explain the loss function. Loss function is basically, it's nothing but it's measure how wrong the model's prediction. The goal is basically to minimize the loss. The loss is what over here, it is an error, that combined error what we have after performing this algorithm, after performing this machine learning model. So what we'll get as an error over there. So it's generally measure that loss, how much we have during predicting the value. Next term over here is yi. Yi is over here actual value. The actual value, based on that we're going to predict. So this is nothing but the actual value. Now the next term is over here. Over here you can see that ftxi. Now what does it mean? It represents that model's prediction basically for the ith data point in the current iteration. So think of it as that improvement or correction of the model, and it based on that, it basically it's trying to make the prediction or trying to make that based on the previous iteration. Now the next is over here, this one, this is regularization item. Okay, so the meaning of this basically, it is for preventing the model from fitting the training data too closely. So the meaning of is that if you know that overfitting, so this term is basically used for preventing the model from the overfitting. Now as you can see that one arrow we have. Now what is the downward arrow here? It basically simplifies this whole equation. So this is the complete simplification over here. Now here I want to tell you one more thing, that it says that the entire equation can be thought of as the calculating the change of this x in the function fx. You can see that this x basically. So what is that over here is that is the calculating the change of this delta x in the function x, and in this case x is nothing but is here the previous prediction. So what is the meaning of x over here is, it is the prediction. Prediction is what? Previous prediction of what? Previous prediction of this. I'll write here that previous also, so you will not get confused over here. So this is the complete notation, mathematical notation of XGBoost. Now let's move to the other topic of XGBoost, that attributes, benefits and limitation. First is, you can see that attributes of XGBoost. First one is cross validation. Now what is the meaning of cross validation over here? It has an inbuilt routine to perform cross validation at each iteration, reducing the need for manually tuning the number of boosting rounds. Very complicated. The simple explanation of it is like, as I already discussed, that if you want to buy a pair of shoes, before that you will try multiple pair of shoes, right? So when you try multiple pair of shoes, that means that iteration is there, and then based on that you will choose the final one, the best one. Same here, that cross validation also do. It reduce the need for manually tuning the number of boosting route, and when we perform iterations, then we'll be able to find out the best thing out of it. Next is sparse data handling. Effectively manage sparse data set without the need for pre-processing. Next is block structure. Uses a block structure to support parallel learning. Next attribute of XGBoost is performance. Often provide superior result with its boosting algorithm, especially in structure and tabular data. So basically it works good if you have that complete structured data with you. Let's go to the next one, flexibility. It's obviously the meaning of flexibility over here is that it is flexible with various prediction tasks. As you can see on the screen, that first is regression, another one is classification, then ranking, user defined prediction tasks. So this XGBoost is good to use, and why? Because it is flexible with different prediction tasks. Then after, the next part comes tuning. Allow for easy model tuning resulting in better performance. Here the meaning of tuning, when we tune the model, at last the performance what we get as a prediction, what we get, it would be better if we tune the model. So XGBoost provide you that tuning. Then after is scalability. Here it can handle large data set efficiently due to its ability to parallel computation and optimized speed. It's not only doing that optimization, with that computation is also there, means it can work parallel multiple things. So because of that reason, it is very helpful if you have the large data set. Next is portability. Support major platform and languages, making it portable across different domain. That means it's not only in Python, you can use different languages also, different platform also, if you want to use this XGBoost algorithm for your ML modeling. Now the next point comes, limitation of XGBoost. Obviously if you have something with you as an algorithm, means each and every algorithm has some advantage, obviously then that they have disadvantages as well. So we have some limitation, and here we have first limitation is computational intensity. Now what does it mean? Basically that while XGBoost is faster than traditional gradient boosting, due to parallel processing, which we discussed, that what parallel processing, it can still be computationally intensive, especially with large data set. So this is the limitation. It's actually good that it's faster than the traditional gradient boosting, but again, with that, it has this limitation that it is computationally intensive. Next is tuning complexity. So it provides the tuning, but what limitation we have in terms of that, XGBoost comes with many hyperparameters, and the performance of the model can be sensitive to the configuration. Proper tuning can be time consuming. So the thing is, if obviously you work on large data set, there we generally require the tuning, right? It comes with that, but the reason it can be sensitive to the configuration, and if it is sensitive to the configuration, the next step what we can see here is that tuning obviously will take time. So that's why it sometimes become a time consuming process. Then after overfitting on small data, though we have already discussed that it's good for large data set, but sometimes if you want to work on small data set, there you might come into with the overfitting issue also. So without carefully tuning or regularizing the data, XGBoost can overfit. That means especially if you are dealing with the small data set. What does it mean? Basically, it will work good on training but not on the test data. So there we can see that overfitting might come. Next is noisy data sensitivity. The meaning of noisy data sensitivity over here is what? If the data has too much noise, boosting can overemphasize the noise, leading to suboptimal models. So that noisy data is the limitation, and that generally comes when we use this algorithm. So this all are the limitation. Two more limitation obviously you can see here on screen, that not always the best. It is obvious because if you use other algorithms also, it depends, like it sometimes they work very good on the data set, sometimes they doesn't work properly. So same in XGBoost also, it actually not always the best one. So while XGBoost can perform very well on structured data, structure or we can say tabular data, for some application other models like deep learning might be more suitable, especially with unstructured data. So basically it works good with structure, but what if you have unstructured data? So in that case you have to choose some other process. So as deep learning is good for unstructured, there it doesn't work properly. So that's why if you have a structured data set with you, there you can apply this algorithm. But if you have unstructured data, either you have to convert it into proper structured data, else you should use some other way to perform that modeling. The last limitation what we have here is it requires more memory. As it builds multiple trees, it can consume more memory, especially with large data set. So if you have large data set, so then you will using this XGBoost, basically you will create multiple decision tree there, and if you will create multiple decision tree, so then based on that we'll get multiple prediction, and if you will get multiple predictions there, then you have, at the end you have to work on that average of those many multiple predictions, right? Then only you will get the average of all the prediction, and then only will come to the conclusion that what is the final and the best prediction. So there, following these many processes, obviously it will take time, and when it will take time, that means it will consume more memory there. So it requires more memory. That is also a limitation of XGBoost. So now we have covered the limitation, attributes, or we can say a brief introduction of XGBoost. Now we're going to understand more about it. So let's get started. So now we'll understand the meaning of gradient boosting. Not only the meaning, but we're going to understand that why we are choosing XGBoost instead of gradient boosting. Why not ADA boosting? Why not the traditional gradient boosting? And why XGboosting is better than the other algorithm? So that also we're going to cover. So first is we'll understand that gradient boosting. The meaning of gradient boosting over here is it is a machine learning technique for regression and classification in other tasks. Means you can use in regression also, you can use for classification task also. It builds a model from weak learners, typically that here we are mentioning that decision trees, in a stage wise fashion, optimizing for accuracy. So this is gradient boosting, quite similar with XGBoosting, but then why we are focusing here today in this session on XGBoosting, that we'll discuss. Next question is why gradient? So it generalizes boosting to optimize and differentiable loss function. Now what does it mean? That loss function is what? We already discussed that it measures the discrepancies between the predicted and the actual value. So it generalizes that boosting to optimize any differentiable loss function there. That's why we need gradient there. In each stage, it moves toward the direction of steepest descent in the error space. So next point I want to discuss here after that, the benefit of gradient descent. Here first benefit is often it's higher accuracy with few trees. It doesn't work with multiple or lot of trees. We create few trees and based on that it gives higher accuracy. In other boosting method, if you see that XGBoost, there we create more trees, decision trees. If we compare that with this gradient boosting, that traditional method, it can handle missing data and different types of data if it is categorical and numerical, flexible, that can work with any other task, can optimize different loss function also, which is very important if you are modeling your data. So these all are the benefits of gradient descent. What is gradient descent? We have discussed. Why gradient we require that we discussed. Now the next question comes then, why we are using the XGBoost? If gradient boosting is in itself a very good algorithm, if it is very good or good to use, then why we are using that XGBoost? So we'll discuss now the difference between these three methods. That first is XGBoost, then gradient boosting with ADA boosting. We're going to understand the difference in between these three. So first comes is XGBoost. We'll discuss again few bits about this XGBoost, that is extreme gradient boosting. We know already it is an extension, or we can say it is an advanced version of gradient boosting. Features, what comes under this boosting method, it regularization we perform here to avoid that overfitting. So it's very good method, or we can say it's a very good algorithm to avoid the overfitting, because if you are working on large data set and suppose that large data set, if it comes with that overfitting, then it's very difficult to handle that part. So here that regularization we use in XGBoosting, that is very useful to avoid this overfitting. Handling missing data. So if you have missing data, and obviously this method is best for large data set, so it's very difficult to find the missing data there. And if you have missing data and still you are working in terms of, I'm saying, modeling the data, then there you will not get the correct predicted value. So it handles those missing data, which is very important while performing the modeling. Then after parallel processing, which reduce the time somewhere, it perform parallel processing for faster performance. Though somewhere it takes time, it is sometimes a time consuming process, but for faster and for accurate performance, this parallel processing helps. Now we discuss the advantages of this process. Superior in terms of speed and performance. Speed is good, the performance is very good in terms of predicting the values. Highly flexible, can be used for regression, classification and other tasks, can define custom optimization objectives there. Now we have discussed about XGBoost. We'll now switch to gradient boosting. Gradient boosting, we can sometimes refer it as GBM, that is gradient boosting machine. It's a generalization using gradient descent algorithm. Features, what we have in this, it builds tree one at a time, where each tree correct error of the previous one. So one by one it builds the decision tree. because of that parallel processing, that XGBoost is better than this. Uses gradient of loss function to guide tree building. Advantage is versatile with different loss function and can handle mixed data types. Now let's discuss about ADA boosting. Sometimes we refer it as adaptive boosting. It's one of the first boosting algorithm developed. Features, if we say, it assigns weight to observation, and after each step increase weight for wrongly classified observation to prioritize them in the next classifier. Advantages is simple and easy to implement, because obviously it is simple and easy to implement. That is the first boosting algorithm. So the advantages and the benefit what we have in XGboosting that this method doesn't have. Second is less prone to overfitting. Less prone, but it's not good as if we compare with XGBoost. So now you can see that we have discussed that XGBoost, then we discussed the gradient boosting, and then we discussed the ADA boosting. So basically I want to tell you that if I discussed about XGBoost, so here the one point I want to tell you that this is more advanced and we can say that optimized version of gradient boosting. So it is advanced, the first advantage, advanced, and we can say that it is the optimized version, advanced and optimized version, both. So optimized version. Then the next question comes that why we are using this. Okay, fine, it is advanced and optimized version. What about gradient boosting then? If I talk about gradient boosting only, it only focuses on optimization. So this is the difference. It only focuses on optimization. Parallel processing is not there. The next thing and the last part is ADA boosting. The ADA boosting is basically, if I write about ADA boosting here, so what it do? So ADA boosting is actually nothing but it is all about adjusting the weights. So first point is adjust the weights, and why we adjust this weight? For misclassified observations. For this purpose we use ADA boosting. So now we have three methods over here: XGBoost, gradient boosting, and ADA boosting. Why do we use XGBoost? Advanced version. Gradient boosting only focuses or basically focuses on optimization. ADA boosting is just on do that adjustment part, adjusting the weights for misclassification or misclassified observation. So out of these three, that's why we prefer XGBoost. Why? Because it works so good with larger data set. So this is all about the difference between all these three methods and why we opt XGBoost, that we discussed. Now we're going to understand XGBoost versus random forest. So this is a complete picture that the difference between XGBoost and random forest. So the first point over here is the definition that optimized gradient boosting library, and the random forest is ensemble with multiple decision trees, outputs, mode or mean prediction. So this is the definition, that it ensemble with multiple decision tree. It optimized gradient boosting library when we talk about XGBoost. The second is the model building part, that gradient boosting framework. The model building is based on gradient boosting framework. The next is, if we talk about random forest, the model building based on multiple decision tree during training. The next, what about the speed and performance? So when we talk about XGBoost, it is more faster. And faster in terms of what? Faster in terms of if we have a large data set. But when we go to this random forest, though it is a good algorithm, but it is slow for larger data set. Next is a very important term, that is overfitting. In terms of overfitting, XGBoost if we discuss, then regularization prevents overfitting here. So there is something which prevents this overfitting. When we go to this random forest, you can see there that averaging tree result reduces overfitting. Like how it reduces? Averaging the tree result, it reduces the overfitting. Here regularization method we use to prevent the overfitting. Next is missing data handling, inbuilt routine for missing values. So there is in XGBoost there is already an inbuilt routine to handle those missing values, which is very important to handle. And here if you have missing values, for that you need to perform that imputation method. That means you need to impute the missing values with either mean or mod. So there is no inbuilt routine for that in random forest, but that we have in XGBoost. Then last difference between these two is interpretability. That means that feature importance scores. When we perform this XGBoost, when we apply this, at last we can check that that feature importance scores there, which feature is more important, so we can focus on that. And here that importance we can check and insight into trees also. So this is the difference between XGBoost and random forest. Then after now we're going to understand that how this XGBoost works. So now let's understand how XGBoost works. Here you can see a lot of pointers which I have mentioned on the slide. That first is initialization, then loss function, compute residuals. What is the meaning of these all? So first we'll talk about initialization. These all actually comes under the working of XGBoost. So the first point is initialization. The meaning of that is each observation is initially assigned a predictive value there, which can be the mean for regression or the probability for classification of the target variable. So this is the complete explanation which comes under initialization. Then we move to loss function. We have already talked about it, but the meaning of that is that specific loss function. Over here the meaning of loss function is the specific loss function depends on the type of problem you are solving. So it quantifies how well a prediction model is performing by measuring the discrepancies between the predicted value and the actual value. Now the next point comes that compute residuals. Residuals is nothing but it's the difference between the predicted and the actual value. So here it actually explaining what that in XGBoost the residuals are used as the pseudo residuals, or we can say that gradients guiding the direction in which the model needs that improvement. So if you want to know that where we need to improve the model, so for that we have to compute the residuals. The next over here is before that prediction update, construct a decision tree. Now the meaning of decision tree is what? That we create multiple decision tree in XGBoost. A decision tree is constructed to correct the mistake made by the previous tree. So it is a flow. So the tree is constructed using what features of the data set. And the second is the depth of the tree is controlled by the hyperparameters. So the meaning of construct a decision tree is the next point in XGBoost is after computing the residuals, we need to construct these trees. And why to construct? Just to correct the mistakes made by the previous tree. Now the next point is prediction update. After the decision tree is constructed, it makes predictions on the training data. So the meaning of this, that it makes prediction on the training data once we construct the decision tree. After that prediction update, here we have what? Regularization. Now what does it mean? It is very important term in XGBoost. XGBoost introduce a regularization term which helps in preventing overfitting, results in a generalized model. Regularization can be controlled using hyperparameter. That means that hyperparameter tuning. The next point over here is iteratively add trees. Iteration means again and again to repeat the process. So step 3 to 5 basically are repeated to add more trees. And why we are repeating that? With each tree Our aim is there to correct these residuals from the previous constructed tree. So the number of trees here is the number of iterations. So it is a hyperparameter to be, the number of trees is basically what here, it is a hyperparameter to be specified. The number of trees over here, we can say that iterations. Next is tree pruning. The meaning of tree pruning over here is that XGBoost starts with a deep tree and prunes it back. So how it prunes it back? By using max depth hyperparameter. We'll discuss when we do the hands-on part. Then here the next point is handling missing data. XGBoost can naturally handle the missing data because that inbuilt process is there. So because of that, it handles missing data naturally, and we do not need that imputation part there then. In simple language, I'll explain you here that pruning first, that tree pruning in the context of decision tree is cutting back or removing branches of what? The decision from the trees. Now it's just like if you might prune a plant, or we can say a tree in your garden. So there we can see that why we do that, to keep that tree healthy. Why we cut the branch, that leaves, that leaf which is we can say that sometimes we prune it just to keep it healthy, right? So same preventing it from growing too wild, we cut sometime, right? So in that way, same here also, we prune some branches. That branches act like a decision there from the tree to get the final and the best result. So that pruning is very important here, that we have to do. After that is shrinkage and column subsampling. So what does it mean, shrinkage and column subsampling? So here XGBoost introduced the concept of shrinkage controlled by the learning rate, which scales the contribution of each tree. It can also sample a fraction of the columns. Columns over here are features at each split, and introducing the randomness and making the model more robust. After that, we have parallelization and distributed computing. Now here in this point, I would love to tell you that what is it meaning over here, that why do we require this step over here, that it can also be run on distributed environment, which is a plus point of it, and making it suitable for training on large data set. So parallelization and distribution computing is a plus point. The reason, because it makes the model suitable for large data set. The next is cross validation. Cross validation, here in this cross validation, basically XGBoost includes an efficient implementation of k-fold cross validation, which can be used for hyperparameter tuning. Once the iterative process, that repetition, stops, you will left with an ensemble of trees that collectively decide the final prediction. So it's like the average of prediction. Once we get the average out of all the predicted trees, then we get the average, and then we'll get the final prediction out of that. So that can be done by using cross validation if it is required there. So this is all about how XGBoost works. Now the next part would be that what are the various steps comes under while we model our data. So let's discuss that. So now, as we have already discussed about how XGBoost works, we're going to discuss now the steps to be covered while performing this method. First should be the data preparation. Ensure the data is in numeric format. Handle missing values. XGBoost can handle them, but it's sometimes better to pre-process. Split data into training and testing. So this is these all 3 points comes under data preparation. Now the second one is setting parameter. Setting parameters, you can see that 4 pointers we have over here. First is a learning rate. The meaning of that, the step sizes at each boosting step. Max depth, maximum depth of the decision tree. How much depth you want. Whenever we create a decision tree, so the depth, how much you want there, so that will come under that maximum depth. There we have to define it. and estimators number of boosting rounds or tree to build. So maximum depth is actually the height of the tree, we can say, but the estimator is what over here, that how many times that repetition you want, how many times boosting rounds you want, or how many times boosting trees to build there. Then after objective specifies the learning task. For an example here, that regression and or classification. The next step would be training a model. Once you will set the parameter, before that once you will complete the data preparation. In data preparation, a lot of other things are also there. For an example, like will not handle only the missing values, but you have to check whether do we have any duplicate values there or not. So that also you have to check. We have to perform some analysis, that data that comes under that EDA. So just to check that how that complete data set and what is the complete information we are getting using that data, because you cannot visualize the data if you are seeing those data values manually. So for that you have to visualize using various charts. But in data preparation, first you have to do that missing values handling, and duplicacy also you have to check. Now in training a model, once you will perform these two things, then after you have to use that XGBoost.train function or XGBoost scikit-learn, which is compatible with API, that is XGB classifier and XGB regressor. If it is classification, then classifier will use, or if it is a regression, then there we use XGB regressor. The next is, once you will train the model, making predictions. Use predict method that we do or we apply on the trained model, because once our model get trained, then based on that only we can do the predictions. For classification, it can output probabilities or class labels. Evaluation and metrics. For classification, what all the metrics we have here: accuracy, confusion matrix, AUC, ROC curve. For regression, we generally prefer mean squared error, that is MSE, root mean squared error, that is RMSE, which gives you the error rate. Then after cross validation, that if it is required, use XGBoost.cv function for an efficient implementation of cross validation specific to XGBoost. The last would be model visualization and interpretation. Once we perform all these steps, that means you can now visualize that complete tree structure, and based on that we can interpret that how your model performed and the performance is good or not, and based on the MSE, RMSE scores, or if it is a classification task, then based on accuracy, confusion matrix and AUC, ROC. So as we have covered till now that how XGBoost work, what is the meaning of XGBoost over here, why do we prefer XGBoost for larger data set, let's discuss using hands-on. We're going to apply this model, we're going to implement this model on our data set, but before that we need to install or we need to import some required libraries. If you have already that XGBoost installed, then we can directly go with that libraries like to import that pandas library, numpy library. But if we don't have, then for that we need to give over here this code, that pip install pandas XGBoost scikit-learn matplotlib. This is the code to install this XGBoost over here, and when we run this, it will install all the required requirement which comes under this installation. Once it will get done, then we're going to start implementing the XGBoost method on our data set. So all the requirement we have installed, it's already there. Now we're going to use a few libraries here, and if you want to use few libraries, first you have to import that. So let's first import pandas as PD. Then after, the next would be import XGBoost as XGB, which is, we can say, a nickname. Now the next one is what we required here. If you want to visualize the data set, for that you need to import the required libraries. So we will import the matplotlib.py plot. We can give a short name over here, that as PLT. So if you want to use this, you can use, instead of complete matplotlib.py plot, you can use here PLT. Matplotlib we have used. Now the next is let's say that Seaborn also we can use for advanced plot. If you want to visualize using advanced plot, then there it actually very helpful. So Seaborn as SNS. Now the next is we will going to split our data into train and test. For that also we need to give a code, that sklearn dot model underscore selection, and from there you have to import what, trend underscore test underscore split. So what is explaining over here, that we want to import the train test split. Once we will import, then only you will be able to split your data set into training set or testing set. After that we will going to use from again sklearn dot matrix. We will import mean, squared, error and accuracy score also. So these two we are importing here. That first is mean square error, because we are going to calculate that error in between, how much error we will get in between the actual and the predicted value, and the accuracy score also you need to import that. Now let's create a variable. Here you can see that we have created a variable, and we are using that sales category data over here, which is in the form of CSV. So that's why we are using read underscore CSV function. Once we run this, so our data automatically will get load to the variable. The name of that variable is data over here. Now the next thing what we're going to do, we're going to understand the data dot describe. Now what does it mean? When I will run this code, you can see that complete description, the statistical description of the data set, what we loaded over here. So the number of counts, the mean of the columns what we have in our data set, then standard deviation, then minimum value, that which one is the minimum in product ID, which one is the minimum value in sales column, and which one is in the profit margin. Same 25%, 50%, 75%, these all are the quartiles, and the value what we have here is 25% quartile value in the sales is 1612. So these all are the statistical description of our data, which is very important to understand. Now the next one is, and we're going to understand more about this. So how we'll do that? Let's give a code for that. The data within square bracket, we'll put one more bracket here. Within that, first column is sales. Let's give sales over here. Then within inverted comma, again I will use, then another one is I'm using here this profit margin. So now then next is we're going to visualize these two columns. So first is we are using two columns, sales and profit margin, because that product ID is simply the ID for these values. Next, to visualize using histogram, we have to give the function over here is hist. Within that, we're going to give bins. How many bins do we want here? Let's say 30, and the size of that figure should be fixed size equal to within bracket 10 comma 5. So this is the complete values what we should give while creating histogram. Next would be what? That now we want to visualize using histogram. So for that we will give over here a code, that plt.show. So here we have two columns. We want to visualize this data in the form of histogram, and these two are what the frequency also. You will understand this that 1000, 2000, 3000, these are the cells value, and it's going till the highest one is for 1000, going till 8 frequency. And here you can see that profit margin, that 0.1, 0.2, 0.3 is basically the margin, that 1%, 2% based on that, and you can easily visualize this using histogram. As we are visualizing, first we should see before this that the first 5 values also, that generally we do whenever we start with data analysis. So before the describe, I will give one more code that will give you what the first 5 values that we can do by using head function. So let's first see that what values do we have here. That numerical values, describe function is giving you the 2 columns. The reason is because it gives you statistical information, and the statistical information obviously you can get only if you have the numerical values. Now 4 columns we have. First is that product ID, category, sales, profit margin. Head function will give you the starting 5 values, and it starts from 0. So electronics, these all are the values. After that, once we see that first 5 rows of our data set, next we can do here that to get the complete information. So that how I can do that, by giving this code, that data.info. It's giving you the complete information about all these columns over here. So first is product ID, it's non-null column, and the data type of this column is int64, that means integer. Then after category, and this is how many values do we have, 100 values, and the data type is object. Sales we have here, which is of float data type. Same profit margin, again float data type. Float data type basically that you have the values in decimal or without decimal. If it is integer, then it's without decimal. So product ID is without decimal because it's just an ID, so it should generally we should give without decimal, and the sales and profit can be in decimal. So that's why we are using here data type that float. If it is not float and if you have decimal values, then there you have to convert it. So yeah, now we have discussed here that the first 5 rows, we have discussed the info, we have discussed the summary statistic, we have visualized the data set. You can visualize more by using different charts. We are visualizing over here using that means that histogram. Next code would be that if you want to get the information that how all the variables are correlated with each other. Correlation basically what is, in a simple language I can explain you that if you increase one value, so because of that one value, the other value, the impact of that value, how much we have on the other one, means if we are increasing one variable, that other variable either it will get decrease or it will get increase or it will be neutral. So that correlation, the relationship between two variables, if we want to check that what is the impact of one variable over the other, so that we can understand using correlation. So here I'll understand that, and we'll understand how to get that correlation thing. Here first the code would be the data variable in which we have our data set. Within a square bracket, I'll give the column name for which you want to understand the correlation matrix. So first is sales, the next would be profit margin. So the correlation you can only check if you have the numerical column. There only you will be able to see that because of one variable how that other variable is getting impacted. So here the thing is that we have 2 numerical variable only in our data set. One is sales and profit margin. So let's apply the code to get the correlation there. So after this I'll write CORR, that is the function to find out the correlation between these 2 variables. So you can see that two variables, I told you that either one variable will get increased by decreasing the other one, or both will increase parallelly, or otherwise both will be neutral. So two variable, as if now you can see sales and sales, so there will be no change, right? So here we are getting, because of the reason 100% correlation. Basically this is a kind of, we can say, zero correlation. If we compare sales column and profit margin, you can see that here you are getting negative value. The profit margin actually depends on the sales. So because of one value, the other value either will get increase or decrease. So here they both are negatively correlated, and if we increase one, the other will get decreased. So based on that, that's how we can check the correlation between two variable or more than that. The profit margin and sales, we can see that again the negative, the values are same because the columns are same, and the profit margin, there is correlation, basically that zero correlation. So that's how we can check. If you want to visualize it, means if you want to visualize these values via chart, so there you can use heat map. Now what next step would be, we're going to encode the data. So how to encode the data? For that, I'll give a code. First I will create a variable and I'm giving the name data underscore encoded. The next would be pd.get underscore dummies, and within bracket I'll give the name of the variable for which you are creating this complete process, means for which you are encoding. So that is data. Columns here, which one we want to encode? It should be category. Because why we are encoding this? We are encoding this because this variable is having the data type object. It is of object data type, and if you have object data type, you have to encode in numerical category, or we can say numerical data type, because then only you will be able to do that modeling process there. So after that encoding of category, that column, after defining the column category here, we are giving one more part here, that is drop first true. So we have encoded our data, not data, from the data we have encoded that column, which is the name of that column is category. So now after encoding our variable, let's see the final and the updated data type. So by using info function, you can see that we have now two categories. One category is of furniture, the other one is of stationery, and we have converted those into uint. Now this is not an object data type, it is now a numerical data type. So now we can perform the data modeling over this data. Next part would be, we're going to give the code for splitting the data. So splitting the data into training set and testing set. So how to do that? We have already given a code for that. If you see, if you remember, in the starting only we have given that from sklearn .model selection, import train and test split. I'll give again here that will give you clarity how to do that splitting. So first what you have to do, from sklearn .model underscore selection, import. Here we have to import what? Train underscore test split. Once you will do that, we will be able to split our data set. I'm writing it again, that is import. Now the next code, we're going to create two variables. One variable will store all the training set, one variable will store the independent variable, and the independent variable which all are dependent on that one variable, that will give in y. So two variables will create. I'm creating first, that is x, and data underscore encoded dot drop. We will going to predict based on one column, and here the column is sales. So the complete training set means that complete independent variable set will store in X. So here we have to draw from this data encoded variable that sales column, and that we have to store in a different variable, so then we can perform the modeling part. So here I am dropping that column, that data encoded drop sales, and X is equal to 1. So why we are dropping here sales? Because here we are predicting sales only. We're going to predict based on sales column. The next would be, we'll create one more variable, data underscore encoded. Within bracket we'll write sales. All this sales value based on which we're going to perform the prediction, we're going to perform the modeling, data modeling is sales, and we are storing that in the variable y. Now we're going to create what? X underscore train. We're going to split now our data set into training and testing data. X underscore train is the name of the variable of training data of based on X variable, X test, comma, Y train, comma, Y test, equal to, we're going to split now. So we're going to use this function train underscore test underscore split. Now within bracket, which particular variable you want to split. So here you have to give the name of those variable, X comma Y comma test size. It should be here that 0.2. Now after giving the test size, we're going to use that random state. The random state would be 42. So now this is the complete code. When we run that, we'll get 4 variables. First for X variable train and test, one other one is on which we are doing the prediction, that is Y variable, that will split into train and test. So now it's successfully we have already run this code. Now we're going to perform the next step, and the next step is we're going to import the XGBoost. So now how to import the XGBoost? We'll use import XGBoost as XGB. Here we're going to create a model. We're going to perform this, and we're going to store that obviously in some variable, and here we are creating for that model. So the name of that is model variable XGB dot XGB regressor. Regressor why? Because this is regressor task, that means regression task. So regressor within bracket objective would be within bracket reg, which is regressor, and squared error. So here we are doing nothing, we are doing what? Basically we are calling the model, which is XGB regressor, and we are storing it in the variable, and the name of the variable over here is model only. The next part would be, we're going to fit the model. Where we're going to fit? X underscore train, comma, Y underscore train. So now we have we can see that we have fit the model on X train and Y train. It's already you can see that XGB regressor. The next step would be that we're going to predict. We're going to predict like how? We're going to create a predict variable. So before that, we need to give a code here, that from sklearn dot matrix. From sklearn dot matrix, we're going to import what? Mean squared error. So that we're going to import. Though we have already imported this mean squared error, but it just we are recalling it by giving it again here. And the next we're going to create a variable ypred equal to model dot predict, and here we'll call X test. So we have already done that model dot fit part. Now we're going to check the prediction we're going to perform on X test. After once we'll do this, we'll create one variable with the name MSE. MSE is nothing but it's mean squared error. So here we'll call this mean, which we have already imported, that mean underscore squared underscore error, and based on what? Based on y test comma y print. Next we're going to print now. What we're going to print? Mean squared error, within curly bracket we're going to call this MSE. We'll close it. So after giving this code, we'll run this and we can see that mean squared error over here is this much. It depends on like what value you have. Lower, if you have lower mean squared error, that means the model which you have used predicted more correct values and the accuracy is good there. If you have high mean squared error, that means low performance of the model. Now the next and last part of this, that if you want to check the importance of the features, means which feature is important for this particular predicted variable, so that we can do by giving this code, that first you have to create a variable and we are naming it as importance equal to pd dot data frame. Within bracket we're going to give the feature. This is the code to get the important features, and first while giving this feature we'll put colon over here. We'll call x dot columns comma, within this I'm giving importance. After this again we'll have to put the colon here, and we have to call that from model we want what? Feature importance. So while giving this feature importance, I'll close it. Okay, I'll close it with curly braces, and then after with the main bracket. Once it will get done, the next code would be, we have to print now. So what we're going to print here? Print importance dot sort values by importance, and it should be in ascending or descending, that we will discuss while giving this. Ascending, if you give false, so if you give true, then will be in ascending, not in the descending order. So once we'll run this code, so now we can see that when we run this code, we are getting the name of the features over here. Features is not only is simply the column names, and which one is the important one over here, that the category furniture is actually has that impact and on sales, and you can see that 69% of importance this column has here. Then after profit margin, then product ID. Product ID we can over here ignore, it's just because it is a part of the data set, so it's showing in that way. Then after category, stationery is the last one, which has the least importance in terms of the sales. So this category furniture has the highest importance. So this is all about XGBoost, like how to work with XGBoost, how to apply this XGBoost on our data set, and how to get the importance of the features by using the code what I have given here. Now after this you can apply these codes based on the different data set. You can use a larger data set. If we have larger data set, then what MSE, that squared error we are getting there, that is the model is performing good there, if the performance is good, so that we can check better, and that model is actually handling the missing values or not, that you can understand. So I want you now to apply the complete code or explore it more on different data set to understand more about this XGBoost. Now let's conclude this XGBoost, that what we have discussed so far. First, we have discussed that XGBoost is nothing but it is an optimized distributed gradient boosting library designed for efficiency, flexibility and portability, also scalability. Then after, XGBoost offers parallel tree boosting, handling of missing data and regularization. It's known for high performance but requires careful tuning. Gradient boosting is nothing but is a machine learning technique that builds a predictive model in a stage-wise manner by correcting errors of prior models. Then we covered that while XGBoost and gradient boosting improve accuracy by correcting residuals, AdaBoost corrects misclassification, and XGBoost is often faster and more scalable than gradient boosting and AdaBoosting. The next thing what we covered here is that both are ensemble method. XGBoost builds tree sequentially, both here is random forest and XGBoost. So XGBoost build tree sequentially, optimizing a loss function, while random forest build multiple deep trees in parallel. Then after, we covered that XGBoost iteratively adds trees that corrects error from the previous tree, that is prior tree, using both column block or parallelism and regularization to prevent overfitting there. After that, we have covered today that utilizing the XGBoost algorithm for predictive modeling involves data preprocessing, parameter tuning, training and evaluation. At last, we understood how to demonstrate their using various Python codes, a practical demonstration or tutorial we can say, that showing the step-by-step process of implementing XGBoost on a dataset. So this is all about XGBoost. I hope you understood that the meaning and the importance of XGBoost. If you want to explore more, explore it, understand and try to figure out that which one is the best for the larger data set, and if it is not large, then which one is best for the small data set.